Okay, so we're going to talk about asymptotes in section 5 of chapter 3. And asymptotes are basically boundaries that our graph cannot cross. So they're boundaries the graph doesn't cross. And we have vertical asymptotes, so vertical lines. So we have a line, a vertical line, so vertical line that the graph doesn't cross. So an asymptote, as we get closer and closer to x, so if I have a vertical boundary here, vertical asymptote, our graph can get closer and closer to this. So our x's can get really, really close to this line, but our y values, I'll never have a y value, so that's why it approaches this and doesn't cross. It gets smaller and smaller and smaller, but never reaches that line. Okay, same thing on this side. As I get close and close and closer, my y values go up and up and up. Right? So vertical asymptotes are vertical lines that the graph doesn't cross. Horizontal asymptotes are horizontal lines that our graph doesn't cross. The thing about horizontal asymptotes is there are some chances that it does cross, but what happens is something like this. So with horizontal asymptotes, I might have a horizontal asymptote down here, and what might happen is normally it doesn't cross that line and it approaches, it gets really, really close. Well, sometimes it might cross it once at this spot, but then it comes back around and it doesn't cross it on this side. Okay, so sometimes that happens, but with vertical ones, they will never cross vertical ones because that makes our denominator 0. So vertical ones are x equals, and horizontal ones are y equals. So to find the vertical asymptotes, we set the denominator equal to 0. Equal to 0, and solve for our variable or solve for x. Solve for x. So that's why it's x equals, and it's a vertical line. And you usually draw it by a dotted line or a dashed line. Okay, the horizontal one, to find the horizontal, is a little more trickier, right? With 1 over x, if that's our function, then it's just y equals 0, right? Unless, kind of like I pointed out last video, but I didn't do on the first one, which I should have, unless you're adding k at the end, that k will move it down, so your horizontal asymptote will always be y equals your k. So that kind of moves it up and down. Okay, so this one, so we know that it's basically y equals k. So notice that the degree of the denominator is 1 and the degree of the numerator is actually 0 on the reciprocal function. Alright, so notice that the degree of the denominator is bigger. So we're looking really at the degree of the numerator and denominator. And if the degree of the denominator is bigger than the numerator, then, so if the degree of the denominator is bigger than the degree of the numerator, then it will be, the horizontal asymptote will be y equals 0, unless we're adding something after our fraction. If we're adding something, then it's y equals k. But that's after we take the fraction, right? So after the fraction, if you're adding something or subtracting from it, then it's y equals k. Most of these will be, if the degree of the denominator is bigger, it'll be y equals 0. Okay, so if you see something like this, y equals x squared minus 3x plus 2. And over here is x cubed minus 3x plus 4. The degree of the denominator is bigger, right? So this would be y equals 0. Now if there's a subtract 1 after the fact on that, then it would be y equals negative 1. Okay? Or sorry, not negative 1. I said negative 1. Why did I write negative k? Negative 1, right? But if that's not there, right, if there's no k at the end, notice that k does not have an x on it, right? So that number would not have an x on it. So that would just come back to y equals 0. And that's most cases. When the degree of the denominator is bigger, it's always going to be y equals 0 unless you're adding or subtracting a plain number, right? Some kind of whole number or integer or something like that with no variable. Okay, then if the degree of the denominator is equal to that of the numerator, degree of the numerator, then your horizontal asymptote will be y equals the lead coefficient of the numerator divided by the lead coefficient of the denominator. So here's an example. Y equals 3x squared plus 2x minus 1 over 4x squared plus 2x plus 7. Okay, so the degree of the denominator is the same as that of the numerator. So it would just be y equals, the horizontal asymptote will be y equals 3 over 4. Okay? Because what's happening really here is you're looking at what's happening at the end behavior. As I plug in bigger and bigger numbers like a million, this isn't really going to matter, right? And when I plug in a million, this isn't going to matter. So really I just have a 3x squared over 4x squared. Well, the x squareds are going to cancel out, and I get my y values are just going to approach 3/4. Same thing with negatives, right? When I plug in negatives, what's going to happen? This is not going to matter. This is not going to matter. Square, and then I have 3x squared over 4x squared. Those cancel out, so I get 3/4. So it's going to approach that line y equals 3/4. Same thing up here. When I plug in bigger and bigger numbers, this linear and constant is going to drop off, right? So then I'm looking at x squared over x cubed, and x squared over x cubed is just y equals 1 over x, right? And as this gets bigger and bigger and bigger, it goes closer and closer. It approaches, right? It approaches 0. So that's the degree of the horizontal asymptote and the vertical asymptote. One more thing though, right? You should be saying there's one more scenario, right? So if the numerator is bigger, the degree of the numerator is bigger than that of the degree of the denominator, then what you have is you have no horizontal asymptote, and what you have is a oblique asymptote. So maybe spell this right, oblique, U-E. So you have an oblique asymptote. What that means is it's going to be a horizontal line, so you would have a horizontal line like that or like that as an asymptote. So your graph would approach that horizontal asymptote, maybe something like this, and maybe something like this, right? It's still going to approach it and get closer and closer, but it's never going to touch it, right? But it's just horizontal. And so here's an example. Y equals, say, x squared minus 1 over, say, x squared plus 1. Let me make sure. Oh, this needs to be bigger, sorry. X cubed. Yeah, x cubed minus 1. Okay, so the degree of the numerator is bigger, right? Because as we get larger and larger and larger, right, these don't matter. So the bigger one is going to be x cubed over x, right? So what will happen is that you actually would have to divide these by synthetic division or by long division. So the best one is actually probably change this to probably do this be squared and that be linear. Okay, so then I could do synthetic division here, right? I could do 1, 1, 0, negative 1, and set this equal to 0. That'd be negative 1 for my x. Put that in my box, negative 1. Run it through synthetic division. Negative 1 and positive 1, 0. So what that means is this linear part, y equals x, right? Because we went from x squared to now this is x minus 1. This y equals x minus 1 is linear, right? So it's a linear line. So that would be up 1 or down 1, and then up 1 over 1. This would be my oblique asymptote. Okay, it'd be my linear part of that division there. Okay, so that's how you find asymptotes. Okay, so here we go. We want to find the asymptotes for each of these graphs. Okay, so vertical asymptote, we set the denominators equal to 0, right? So x plus 9 equals 0, x minus 4 equals 0, and x minus 1 equals 0. Okay, the only thing with the horizontal asymptote that you got to worry about is when it's squared, right? And we talked about this in, I think, the first video, right? When we have a quadratic, we need to factor that, because then if the factor of the numerator in the numerator is the same as the factor in the denominator, that means we're not going to have a vertical asymptote. We're going to have a hole at that x value of the denominator, like it's a 0. Okay, and I can do one like that. Okay, so set these each equal to 0. So this is x equals negative 9 is a vertical asymptote. This is x equals 4. This is x equals 1. So there's all my vertical asymptotes. Now horizontal asymptotes are, we look at the degree of the numerator, degree of the denominator. This degree of the denominator is bigger, right? So that is y equals 0. This one, they are the same, so it's my lead coefficients, 2 over 1. So y equals 2. This one, the numerator is bigger, so then we would have to actually divide those, right? So since this bottom is linear, I can go ahead and do synthetic division. So 1, 0, 4. What's going to go in the box is what makes the denominator 0, which would be a positive 1. Run it through. Okay, and then we rewrite that as a polynomial. So y equals x plus 1, and then plus the remainder, right? But this part right here, this linear part, is always my oblique, right? Because it's a line, and it's kind of like a diagonal line, right? So that would be my oblique, y equals x plus 1. So why I really care about just the linear part there is because as x gets bigger and bigger, this x minus 1 is going to get bigger and bigger and bigger, and 5 divided by a million is really, really close to 0, so that's why that doesn't matter. And then we just look at this y equals x plus 1. And we can graph that, right? We go, our y-intercept is plus 1, our slope is 1, so up 1 over 1, and then we could draw our oblique asymptote. Okay, so another one real quick, say y equals x squared plus 3x plus 2 over x squared plus say 4x plus 4. Alright, so when we have quadratics, we can set the denominator equal to 0 to find our vertical asymptote. So when we set this equal to 0, we notice that it's not a linear equation, so it's a little bit harder to solve, right? It's a quadratic, so that means I would have to do quadratic formula or completing the square, or actually the only thing that you really want to do here, really. You can do those, but these are ways just to try to factor first, right? Which all these are going to be factorable. So we actually going to factor the top and the bottom, but let's go ahead and factor the bottom. What times what is 4, but adds up to 4, that's 2 and 2. Okay, so we can solve these, so that's, right, x equals negative 2 and x equals negative 2. So there would be my vertical asymptote, right? But what happens here is when I factor the top, what times what is 2 but adds to 3, that would be 2 and 1, right? So really I can reduce this fraction as x plus 2 into the factors, and then I can cancel like factors. Okay, so x plus 2 and x plus 2. So normally you probably wouldn't have x plus 2 and x plus 2 on bottom, but here these can cancel out, right? So this is the same as x plus 1 over x plus 2. So here, one of these factors is a vertical asymptote, right? And since I canceled this one out, whichever factors I can cancel out, that 0, say it's this one, is the one that canceled out, that would be a hole at that point. So at x equals -2, you have a hole there. Okay, so then when you graph that at -2, 1, 2, wherever that y value is, you would have a hole there, an open circle, right? But this one is a little different because we have common factors, so we still can't, after we cancel that, we still can't have -2 because that'd be undefined, so that's why it's vertical asymptote. Usually you would have something else like, say, this one would be, say, x plus 3, right? So that would be -3. So -3, there would be a vertical asymptote, and then at x equals -2, there would be a hole there, right? So I would find the y value at -2 and put an open circle instead of a solid circle at that point. Okay, so here's your homework on page 353, 37, 39, 41. So you can go ahead and try those out, and you can come back and watch the video of me doing them. Okay, so I'm asked to find the vertical asymptote and the horizontal asymptote, or the oblique asymptote if there's no horizontal. Okay, so the denominator is bigger than the numerator, so that is y equals 0 for the horizontal. Vertical, set the denominator equals 0, so that means x equals 5. I have no common factors to cancel, so x equals 5 is a vertical asymptote. So there's 37. Okay, here's 39, vertical asymptote, horizontal asymptote, or if we don't have one, the oblique one. So we look at the degree of the denominator. It is 1. The degree of the numerator, even though this is backwards, the degree of numerator is 1, right? That's the largest exponent. So 1 over 1, those are the same, so we take the lead coefficient over the lead coefficient. Now the lead coefficient's not 4, that's the constant, right? The lead coefficient is in front of the term with the largest exponent, right? So that'd be -3 over 2. So -3 over 2. So y equals -3 over 2. And then vertical asymptote, set the denominator equals 0. So we add 1 to both sides. So we get 2x equals 1 divided by 2 divided by 2, so 1/2. So x equals 1/2 is our vertical asymptote. 1/2. And we always want to check, probably even with linear, I said mostly quadratic you want to look to factor, but even these you kind of want to look to factor, right? Can I factor anything out of the top? Any number? No. Or any variable? No. Anything out of the bottom? No. So you always want to make sure you check the factor first, right? Okay, so looking at this one, f of x equals x squared minus 1 over x plus 3. So the numerator is bigger, right? So since the numerator is bigger, there's no horizontal asymptote, but there is an oblique. So you would have to do synthetic division. So take your numerator, list the coefficients 1, 0, -1. Set the denominator equals 0. Hey, set that equal to 0 minus 3. Hey, then x equals -3. Isn't that your vertical asymptote? X equals -3. So you already have that done. Plug that in the box, run it through. Okay, so then write your quotient here, which is y equals x, just plain x, right? Because we went from a squared, we're taking x squared and dividing that by x, so that's x, and then minus 3, and then plus your remainder over what you're dividing by. Now again, as we go bigger and bigger x's, this is not going to matter. So our oblique asymptote is the linear equation y equals x minus 3, so that is oblique. I think there's an I before there. Something like that, that is oblique. So there you go, there's the homework for you, all done for you. Okay.